This video is going to cover the topic of order of operations. Be sure to check that you have the date and topic at the top of your paper. We'll also put our essential question at the top. What we want to know today is when we see a problem with multiple operations, how do we know which operation to do first, right? And as always, we haven't been mentioning this, but this margin here is empty for any questions that you might have as we're going along. So let's take a look at a quick number sentence that we might be asked to solve. We have 4 plus 2 divided by 2. There are two possible ways that people might solve this. Someone might set this up and say, well, the first thing I'm going to do is add 4 plus 2. And they'll say, oh, that's 6. And then they'll say, oh, and then I'll divide by 2, and I'll get an answer of 3. Right? That's one way someone might approach it. Someone else might take the exact same number sentence and first do 2 divided by 2, which is 1, and then say, oh, right, and I need to add that 4. And they would get 5. Right? They can't both be right. And obviously, we can't have a system of math where people can do the exact same problem and get two different answers. So how do we know which one is correct? Well, there needed to be a set order in which we do math, right? We need to figure out a way that everyone can agree and count on the fact that we will always come to the same solutions. Mathematicians decided on the order, and we'll give a little bonus to anyone who can research and share how that decision was made. But we call that order the order of operations. The order of operations that they decided upon is the agreed order for completing a math problem with multiple operations. You will also hear me refer to it as something called Pemdas. Let me share why I call it that. In any math problem, we do the work in the following order. The first thing we would do is complete anything inside the parentheses, if the problem had parentheses. The P in Pemdas comes from parentheses. Following the parentheses, we would do any exponents. There's our E from Pemdas. The E stands for exponents. Next, if we see there is any multiplication or division, we do those next. That's our M and our D. The multiplication and division have this little arrow underneath, right? Because we do these first come, first serve from left to right. Right? So we do whichever one we see first. These are kind of tied in importance, so we do them at the same time, right, from left to right. You can probably guess then what our A and our S stand for. These, of course, represent addition and subtraction. And addition and subtraction have that same arrow underneath. We also do these first come, first serve, or left to right. So if we see adding and subtracting in the same problem, we'll do whichever one we see first. All of these letters together form the acronym Pemdas. Let's do a couple of these to see this in action with what I call the snow cone method. I use this snow cone method because it helps keep me organized. I'm going to use Pemdas to solve this number sentence. The first thing I want to check for is whether there are any parentheses in this problem, and there are, so I'm going to do that first. I'm going to circle the operation inside the parentheses and make a little snow cone here to give the solution. So 9 plus 2 would be 11. From there, I'm going to actually rewrite everything that is left. And I know that seems like a lot sometimes, but I notice that it keeps me the best organized that I can be, and it makes sure that I don't miss any pieces as I'm continuing forward. The next thing I want to do is to see if there are any exponents. I don't see any, so I'm going to skip that. And I'm going to move on to my multiply and divide. In this case, there happens to be multiplication, but no division, so I'll just go ahead and do my multiplication. I'm going to circle that and make a little snow cone here. 8 times 11 would be 88, and I'm going to rewrite what is left. Next, I need to see if there's any adding and subtracting. There is subtraction, no addition. So I'm just going to go ahead and circle my last step, make a little snow cone, and I see that my answer is 85, and that's my final answer. If we had done this without order of operations, we might have gotten something completely different and incorrect. Let's try another. This one's much longer, so it's going to be even more important that I use my snow cone method to keep things organized. So the first thing I noticed is that I don't see any parentheses, so I'm going to skip that. But I do see an exponent, right? Right here, I see 3 squared. And remember, 3 squared is 3 times 3, so I get 9. From there, I'm going to rewrite what is left to do. Next, in my Pemdas, I'm going to move on to the M and D, the multiply and divide. I actually see both multiplication and division here. So I need to remember that I deal with these on a first come, first served basis. So in this case, the division comes first. So I need to divide first. 7 divided by 10 is, of course, 7, and then I'll rewrite what is left. From there, I will move to the M, so I'll circle that. I'll do the 9 times 7, or the 7 times 9. I have 2 operations left, a subtraction and an addition. Again, for these 2 operations, I do first come, first serve, so I will subtract first. I get 57 there, and then the last thing I need to write down is that I still have an addition. That'll be my last step. So I get a total of 75. That number sentence was really long, and we could have made a mistake anywhere throughout that, but because I knew my order of operations and I went through bit by bit, I was able to come to my correct answer. For your turn, I want you to think about the order that you would need to use to solve this multi-step problem. And remember that there's an exponent there, so remember what 4 squared means, right? It doesn't mean 4 times 2, it means 4 multiplied by itself. So just be mindful of that as you're solving. And remember, the essential question for this video was how to determine which step to do in a problem that had multiple operations, and there is a defined process that we need to use. So we'll be practicing that more together in class.